Hello viewers, how are you today? I think you are very fine today. By your own efforts, by your own quality, by your own courage in this corona age. Because it's very hard to be fine, hard to be nice this time. Very crisis time this is. Indeed. Excuse me. Today I am going to discuss some astronomical aspect like dark matter and dark energy. We know very little about it yet. It's under yet under the conception and ideas. Not in laboratory or in nature, nobody can prove it visibly or with instrument or with any scientific method. In CERN or in collider, some large hadron collider, it's not possible yet to find the particle consists of the dark matter consists of a small particle. Yeah, but they think that the dark matter is made up of small particle because it is matter. So today we just what we know we can discuss about dark matter and dark energy. What is really dark matter? In our universe, trillions of billions of trillions of galaxy and many other astronomical matters. So celestial matters. Our galaxy is Milky Way. It consists of some trillions of stars, and like our sun, not too many, but lots. Like our sun, the medium-sized star. We have planets. So our planet is we live on Earth. Let's see our galaxy. This is our Milky Way. This is our galaxy, our home. We are the family of stars like Sun. Name is Sun. So in our galaxy, lots of stars like Sun, and they may have some families like planets and like moons. Lots of things they have. It's still yet prediction, and sometimes they predict it with the observation, with whatever they find in observatory with telescope. So in our galaxy there exists dark matter. First we can discuss about dark matter. And the scientists just predict that about 68% is dark energy, 27% dark matter, and only 5% is visible matter. So it's a big kingdom of dark matter and dark energy throughout our galaxy Milky Way. So no way to refute or whatever. We can't refuse this. We can deny this. The existence of Milky Way, existence of dark matter and dark energy in our Milky Way. In every galaxy, everywhere where there is matter, there is dark matter. Because dark matter is always give the attraction force to stay the stars together, whatever in their original position, in their balanced position. So they always resist the stars or astronomical matters to going apart or go in the expansion process. They resist it. So in our Milky Way, there is a big beam of round circle like a ring, like dark matter, which resists our Milky Way, our galaxy, our stars, to going apart from each other, to going in the expansion process of the universe. But the whole galaxy is moving away, going apart, going. It is under expansion of universe. So there's expansion, but our galaxy stay in their, our stars stay in their position because of this attraction force of dark matter. So dark matter gave us energy, big gravitational force to stay together and resist the expansion, resist the going apart. Let's see our dark matter, how it works. This is a conceptual or from imagination. This photograph, the white matters we are watching, that's the gravitational pulls of the dark matters. This is our Milky Way. So Milky Way has existence. How the scientists prove that the dark matter exists. Scientists say if all a disk, our galaxy Milky Way consists of trillions of stars is a disk, circular disk, and it's round and round at the center of the galaxy, around the center of the galaxy with tremendous speed. So in this position, in this case, the speed of the stars at the outer conference or at the outer big axis, or big axis, the speed of the stars should be lower, and at the center, the speed of the stars, lower axis, smaller axis, the speed of the stars should be bigger or larger speed. But in the practical case, the scientists found the two speeds are equal. How this is possible? This is possible due to a gravitational pull, gravitational attraction, or gravitational impact of the dark matter around, encircle our galaxy, encircle our Milky Way. So it is the proof of existence. Though it is very conceptual stage, not yet proved like laboratory or in the nature, or anybody can prove it by mathematical, but it's a conceptual fact. And let's come with the dark energy. It's a big amount around our universe. So dark energy is almost 68%. And dark energy, nobody can, it's not feelable, with our five senses. We can't feel it. But in observatory, we can't see it. But it exists. How scientists prove that it exists? There's a model of the universe about the future of the universe, our universe, or any universe. There are multiple universes according to quantum mechanics. So there's the model about the future, whatever I am saying, that there's the model about the future of our universe. The universe is expanding, it is now proved. So it will expand and expand, and at a point it will stop expanding. And from that point it start crunching, contracting, and at a point it will contract and go to singularity. Again, there will be a big bang after singularity, and again another universe in another form, in another dimension. There will be a universe like our Milky Way. So this model is not working because the universe is expanding at more speed than before. It is proved by Hubble. It is proved after Hubble. So no way we have to expand, and it is unlimited. Expand forever. Einstein says a confined space which has nothing inside assumes nothing inside, but there is something inside. It's not vacuum. What is inside? There is dark energy inside. And if this confined space expands by itself, the space expand the space, the energy inside will not end. It will multiply. That's the concept. The energy in our expanding universe is not the dark energy. In our expanding universe is not decreasing. It's going the same. So what's happening? This dark energy has big impact in the world of force. So we have unified field theory. But we don't have a theory of everything. When we find the theory of everything, we can explain all the phenomena of our universe, of other universe, everything, of the creation of the nature, everything. So still now, we know about dark energy, that it has big impact, and it is a repulsion force, and it helps the universe to expand forever. But the energy will not finish. So it's a conceptual thing. How you compare, how you define this dark matter or dark energy? Dark means it's not visible, it's not feelable. So dark energy and dark matter is about 95% of the universe, and it is not visible. We can compare it with the iceberg. Only 6% of the iceberg is visible above the sea level, above the sea surface, water surface. So whatever I see in the iceberg is not the iceberg. The whole iceberg, about 95% iceberg, is underwater. So we can say that like iceberg, the dark matter and dark energy is beyond our eyes. So our observation. So that's the things around us. So dark matter and dark energy is not antimatter. So antimatter scientists can make, but it's hard to store. In a Large Hadron Collider, CERN, they produce the antimatters, but this is very different things, the dark matter and dark energy. But the concept of dark matter came from Albert Einstein also, but he has a very unique and strange thing which is called the cosmological constant, which go against the dark matter and dark energy. So when it's proved that cosmological constant doesn't work, he says he was wrong. So scientific theory, scientific conception or hypothesis is always changeable. Sometimes nothing is constant. Sometimes it's proved, when it's proved that the later experiment proved that the former one is wrong, then we have to go further. That's the science. Science is not stubborn, not the fact, like constant fact. So it's changed by the observation. So observation and testing, these all the facts of science. So far so good. That's all about dark matter and dark energy. Thank you so much, viewers, staying with me in the discussion of cosmological things, astrophysics, whatever you say. Thank you so much. See you again with any other topics of astronomy.